Hi everyone, welcome to this lecture series on OCI file storage service. And in this particular module, we are going to introduce the file storage service and look at some of its characteristics. My name is Rohit Rahi and I'm part of the Oracle Cloud Infrastructure team. So we have been using this slide to show you the range of storage services available on OCI, starting with local storage, block storage, file storage, and object storage. These have different storage architectures. In this particular module, we are going to look into file storage service. File storage service works on a storage architecture in where you manage data as a file hierarchy. This is in contrast to object storage, which where the storage architecture we manage data as objects, and also in contrast to block storage, where we manage data as blocks within sectors and tracks within physical disk drives. So that's the main high level overview difference between file storage, where you manage data as a file hierarchy, versus block storage, where you manage data as fixed size blocks, versus object storage, where you manage data as objects. And then we'll look into some of the details in subsequent slides. So what are the use cases for the file storage service? There are several use cases, some of which are related to Oracle applications like EBS, which needs and works on file storage requirements. Then you have general purpose file systems. There are scenarios on big data analytics, HPC scale out apps, and several other scenarios where file storage service can be used. So what are some of the features of the file storage service? The first thing is the service is AD local. If you have a multi-AD region, it's a AD local service, supports NFS v3 protocol. It supports network lock management for file locking. It has full POSIX semantics. Data protection, we support snapshot capabilities, and you could create up to 10,000 snapshots per file system. For security, we do support security in the sense of encryption for data at rest for all file systems and metadata. And very soon, we are also going to support encryption in transit for data on the file systems. Of course, you can access the service through the console API, CLIs, SDKs, and all that. You can create 100 file systems and 2 mount targets per AD per account. And of course, these are soft limits. You can always increase them. So let's get into some of the details on what the file storage service entails. What is a mount target? What is a file system? What is an export path, etc. So before I proceed, let me have the ability to write on the screen. So what is a mount target? Right now I'm showing you a region which has two availability domains. Now it can be a single AD region also, and all the concepts I'm going to talk about sort of remain the same. um, so we have a region 2 with two ADs, and just for illustration purposes, I mean, regions have three ADs. I'm just showing this for illustration purposes. We have a VCN, which if you recall from the VCN module, it's a regional service, and it's running at this particular, it has this particular address space. I have two subnets, smaller subnets within the VCN, 10.0.0/24 and 10.0.1.0/24 here, right? So I create this thing called a mount target, which is nothing but an NFS endpoint that lives in your subnet of choice. You can choose to have a mount target created here or in some other subnet or in another AD. It's specific to an AD as it's shown here, and mount target has an IP address and DNS name that you can use in your mount commands. So the simple way to identify a mount target is you get this private IP address which you could use for your for with your file systems. And the way your NFS clients access the file systems is going through the mount target. So you can see there are two NFS clients here in two different ADs, two different subnets, they are accessing a file system right here on this particular mount target. A mount target requires three private IP addresses in the subnet. So it's a good practice to not use a subnet of /30, because a /30 subnet will have only four IP addresses. So three out of the four would be taken up by the mount target. If you have this kind of a scenario where you have a mount target and also an NFS client, an instance, and you have one more instance here, you will run out of IP address spaces because your subnets is too small. So don't use subnets which are /30 or smaller. And you might ask, why do we require three private IP addresses? Two of the IP addresses are used during the mount target creation, and the third IP is used for high availability. And we'll talk about that, how your TCP connections have to survive reboots, or if mount target has a failure. This is highly available, right? So how do we ensure that the mount target stays highly available, right? So the third IP is used for that. We'll talk about this in more detail when we go into the security section. So it's a best practice. The difference between the previous slide, one of the key differences between the previous slide and the next slide is you can see that right here I have the mount target and one of the clients in the same subnet. Now there is no hard requirement uh, which says that you cannot do that. Right now you can see that mount target has its own subnet, and this client instance has its own subnet. They're running in this AD1. Now, placing NFS client and mount target in the same subnet can result in IP conflicts. Why? Because when you create the mount target, you are not shown which IP address is used for the mount target. Like I said, 10.0.0.6, you see this, but there are two more IP addresses which get used, right? We don't know what those two are. And if you don't know those, one of the clients could actually grab one of it, right? One of those IP addresses. Now, it's not a requirement, uh, but it's a good idea to place FSS mount target in its own subnet, the file storage service mount target in subnet, where it can consume IPs as it needs, right? So create its own subnet and let it run there, instead of having a single subnet where you put the mount target as well as you put the instances. But just again, keep in mind, there is no hard rule which says you cannot do that. You absolutely can do it. It's just a good best practice to separate them out. So we talked about mount target and what those are. It's an NFS endpoint, highly available, where you run your file systems. Now, what is a file system? File system is the primary resource for storing files in this file storage service. To access your file systems, you can use an existing mount target, like you see here. This file system is running on this mount target which was already there. Or if you don't have a mount target, you will create a new mount target. We'll look into the demo and you can see how that works. Uh, as we said in the beginning, you can create up to 100 file systems per mount target. It's AD specific, seems pretty reasonable. And then you can access the file system through any of the instances, whether it's virtual machines, bare metal, doesn't matter, or you can access from on-prem through Fast Connect or VPN as well, right? So we looked at mount target, what mount target is. We looked at a file system, but how do you make all this real? Like how is a file system made available? So a file system is made available through a mount target using this concept called export path. Again, a file system is made available through a mount target through this concept called export path. Export path is the unique path specified when the file system is associated with a mount target when you create them during the creation process. So one thing to keep in mind is no two file systems associated with the same mount target can have overlapping export paths. So what do I mean by that? A path like /example and a path like /example/path are not allowed. Why? Because this part is the same between these two export paths, and the system gets confused. It doesn't realize that these are two separate file systems, right? So let's use a graphic to understand that. So that's much simpler. So you create a mount target. We saw that in a couple of slides back, and it's nothing but a highly available NFS endpoint. You get a private IP like this, right? And there are two more IP addresses which are not shown. Export path one can be something like example one, path one, and this can be your file system one. And export path two can be example two slash root example two slash path, and here you can have your second file system. So this is how you would create. Right now I'm showing two. You could create up to 100 file systems per mount target. Now how do you use it, right? Export path along with the mount target IP address is used to mount the file system to an instance. All right, so what do I mean by that? You run a command like this, typical mount command, sudo mount. This is your mount target, this is your export path separated by a colon here, and then this is your directory on the NFS client instance on which external file systems are mounted, right? So in this example here, I have mounting file system 1 to this mount point, and I'm mounting file system 2 to this mount point. So as you create a mount target and a file system, and the next step you have to do is mount them to an instance running in OCI, right? So you launch an instance, you install some of the utilities, NFS utilities if they're not there, and then you just mount them. The process is really straightforward. We just saw this mount command here. You create an instance, you install some of these NFS utilities, you create a mount point, and then you mount you mount the file system with the mount target here, the mount export path here to the local directory on your instance, so the mount point on your instance. And that's how simple it is to use. So with that, let me jump over to the console and show you a quick demo of how FSS file storage service works in action. Thank you for joining this module. Hello everyone, welcome to this module where